Important players, NAD, and FAD. All right, these guys are important players because they temporarily carry electrons in cell respiration and they possess energy. All right, so they're going to carry those electrons on. NAD plus and FAD plus will be reduced at several steps. What does reduced mean? Yes.
It loses oxygen and gains hydrogen.
Leo, the lion goes grr.
Oh,
So gain of electrons. So these are going to gain electrons. And let me just review this real quick. If something positive gains an electron, what is it? Something that has one proton and one electron. Something that has one proton and one electron. Think chemically. One proton, one electron. Element. Hydrogen. All right, so one proton and one electron equals a hydrogen. So if I'm adding, NAD plus is going to become NADH. So we're adding an electron to get that hydrogen. So we're reducing it. All right? I know that's weird. It doesn't really make sense. It's a play on words. All right? In the last step of respiration, ETC, they will be oxidized and will give the hydrogens to the enzymes in the electron transport chain. This will result in the synthesis of ATP. NADH generates more energy per molecule than FADH. So one NADH pretty much is going to equal 3 ATPs, and one FADH2 is going to be 2 ATPs. We'll talk about how to get those in a minute. Yes?
So how come FAD, when you reduce it, you get FADH2?
Why do you get that? Why do you get FADH2? Because this is going to actually have a 2 plus.
Okay, and the NAD is just going.
Remember this little thing right here where it says like the oxidize and reduce form would be
Yep, this is this right here. NAD plus reduces NADH. Oxidize FAD plus, reduce FADH2. That's the chart. Yes.
This one would be, the reduced would be NADH and FADH2.
I would just write them exactly how you see them, and then just label oxidize and reduce. Or NAD plus, and then below that FAD plus. Okay? That's a little bit of an intro. We're going to get into some pretty good detail today on these wonderful things. This is a unit that you have to memorize a lot. You have to memorize a lot of stuff. Starting with the red, starting with the plus is reduced to H. All this stuff you need to memorize. Okay. So here we go. All right. So if you're looking at the structure, what it looks like, the NAD plus, if you're reducing it, you're going to gain a hydrogen. It's also going to give off a hydrogen. So to reduce it, plus 2, here it is, and here's the extra, NADH plus a hydrogen. So you're going to have 2 hydrogens come out. Oxidation is going to remove that and that to be NAD plus. So one way or the other. Not a big deal there. Okay. All right, the removal, decarboxylation, the removal of a carbon atom which is released in the form of carbon dioxide. So remember, when we look at these pictures, that this here is a carbon. What would this be? Huh, what is that? Carboxyl. All right, so we have our carboxyl there, and then we're going to have the RH left, as well as the carbon dioxide. So this guy right here, these guys are left, and this is removed. All right? That's decarboxylation. We're going to be talking about that. We're going to be asking you that again today when you see it in one of the processes. I ask you, oh, carbon dioxide is produced. What process is that? Decarboxylation. Okay? All right, that should be a pretty easy one. All right, buckle up your seatbelt. Here we go. First step, glycolysis, the basics. Glyco is sugar. What sugar is it? Glucose. It is glucose. All right. So glyco is sugar. This sugar that we're dealing with is going to be glucose. Lysis, you need to know, is to split. Anytime we talk about lyse, besides the one in your hair, lysis, split. All right. What does cytolysis mean?
To form.
Cytolysis.
To bring together.
Cytokinesis. The cell is blowing up. Cytolysis, the cell is blowing up. Cyto is cells. We should remember that. All right, glycolysis to split sugar can occur in the absence of oxygen, anaerobic. All right, now, how do you know what if you kept performing glycolysis and then you did the same thing to the pyruvates that it forms? What do you think is going to happen if you're exercising really hard in the absence of oxygen? What builds up? What builds up the next day? Why are you sore? Lactic acid. So from glycolysis, way on down the line, you would form lactic acid. Just so you know that. We'll talk about that in a minute, in a couple minutes. Overall, 6-carbon glucose is broken down by enzymes to 2 3-carbon compounds called pyruvate. Produces a net of 2 ATP, 4 produced, minus 2 used, and 2 NAD plus an H plus. Okay?
Wait.
Yes? I'm waiting. What's the question?
No, I'm not.
All right, so we have 2 3-carbon compounds called pyruvate. We're going to go over this diagram in detail. Yes, question?
Oh, I was wondering, is lysis like, is it strictly split or does it also mean like first?
First, split. Same general type of thing. There are seats up front. This isn't church. You guys can feel free to come on up. There's a seat here. There's a seat here. There's a seat here. It's even closer. Hey, come on down. All right. You can take the big chair. Big girl chair. All right. Okay. Solo, am I good? Can I go? All right.
There was a lot to write down.
Okay. Come on, T. Let's go. Get it together.
I'm good.
Okay. So we're doing these. We're going to talk about these 3 steps today. We're going to talk about this one, and this one, and then we'll talk about this one next class. So that's the 4th. These are the 4 steps you have to know in great detail, to the minutest detail for your feeble brains that you can accept. All right, so I won't go into all the biochem or physical chemistry of it, but as much as I'm required to tell you. So you need to know, let me just ask you this, where is the purple occurring? Cytoplasm. Cytoplasm. All right, so how many ATPs are produced in the cytoplasm?
2.
All right, 2 ATP in cytoplasm. Okay, how much ATP is produced in the, wait a minute, what is that thing? I don't even know what that is.
Mitochondria.
No, it's a mitochondria. Okay, mitochondria. 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 Yeah. How many ATPs are produced in the mitochondria?
34.
Let's see this. So I'm going to write mitochondria. And I'm going to go like this. Well, I have this one. 2 plus this one equals. All right. So from one eine glucose molecule, how many ATP can be made?
36.
How many net ATP?
2.
No, net ATP.
30.
I'm hearing it.
36.
One glucose nets 36.
Nothing entirely.
Yes. Nets 36 ATP. ATP. Okay. So one glucose can net 36 ATP. Good. Okay, so we got the glycolysis. Okay. So glucose, we think of what shape when we think of glucose? Glucose equals sugar. Okay. So let's just do that. Something like that. Okay. That's a pentagon. That wasn't good. Let me try that. Oops. Let me try that again. Yeah, packing geometry. Here we go. Let's try that again. Yes, that's much better. There we go. All right, so we think of a hexagon. Now, for all intensive purposes, we like to think of this as a straight line carbon chain for this activity. So glucose, all right, so we have this guy right here. Here is glucose. Let's take a look. All right, so let's break this down. We talk about glucose. Here it is. All right, but it also says this over here. Glucose diffuses into the cytoplasm from the bloodstream. How does it get into the bloodstream? Thank you. Thank you. From the small intestine. We did talk about that. Of course, we have to have some enzymes breaking it down. But it's going to go into the bloodstream from the small intestine. You guys are you guys, that enzyme video I showed you should have changed your life. How many people are eating raw potatoes? Broccoli? Raw broccoli? I got some pineapple right in the office today. I got some clementines. All right. So from the small intestine, glucose is gonna diffuse into that. Now, in order for this to start working, all right. Let's see. Watch this. Check it out. Watch this, Bob. What do you mean nothing's happening? Is anything happening? Are you watching?
Moving through it.
Well, how is it going to start doing something? By the force. The force is not with me today. I can't move it. I'm trying really hard to move it. Nothing. What do you have to do?
You have to push it.
Yeah, you gotta move it, right? So guess what happens? You think glucose is any different than a water bottle? What do you gotta give it? You gotta give it some energy for a thing to happen. All right, so what we're gonna do that? We're gonna do that right now. We're gonna add 2 ATP, add 2 phosphate groups to the glucose, energizing it. Who can remember what the formula is for this here? 2 ATP to make gives you 2 ATP. So let's see. 2 ATP make
Energy.
Okay, we got energy. What else does it make?
2 ATP.
It produces nitrogen.
Okay, so we're making the ADP. What is oh my God, what is ADP? The diphosphate, adenosine diphosphate. So they're going to lose what? What are they losing? All right, and then here are the phosphates they're losing. They're losing two of them. What's the formula for a phosphate again? PO 3 minus. So now I have two of these, and guess where those two are going? Guess where those two are going to go? Look at this picture. Where is it going to go? Aha! So they're going to go right there. Now, those phosphates are high energy. All right, so they're high energy. All right, so these guys right here, these are high energy. Now, I'm breaking this down to the minutest detail, so you should be successful on this. So if you're writing everything down, you're listening, you're stopping and asking a question, good things are going to happen. All right, so those are high energy. So glucose already had energy in it naturally, but hence like the water bottle, it's just going to sit there until it's acted upon by an outside force, right? Question?
Where did you get the 2 PO?
Oh, this is this. This PI, inorganic phosphate, that's what that
Oh,
is.
the I means inorganic.
Inorganic. So PI means inorganic phosphate. And inorganic phosphate is what? Something that doesn't contain what?
Carbon.
No carbon. Carbon. All right, it's my favorite pirate one. All right, no carbon. So now we got a high energy biphosphate molecule, and what happens is it's so powerful now that this guy and this guy are fighting. He is fighting with him. She and him are fighting. And guess what happens? Yeah, they're going to rip it apart. And they're going to form two energized, they're going to form two P-gal. These are still energized molecules. They're going to form P-gal. So from my technically fructose biphosphate here, we're going to form two P-gals. All right, so make sure you know. Now look, so I have two of these. Two P-gal. All right, so two of those. All right, boom. And then we're going to add another phosphate to that to energize it even more. Question? You don't really need to know phosphoglyceraldehyde, but you don't really need to know that. Okay? Don't need to know phosphoglyceraldehyde. You don't need to know that. Glyceraldehyde. Okay. Don't need to know that. Okay. Just so you know, two P-gals are formed. All right. Can't do it without the girls. All right. Two ATPs are used to phosphorylate. Oh, golly, Jenny Craig, I totally forgot that. Oh, yeah. Aha. Well, this process is called what? Oh, man. The other class had to sit there. They were waiting for a while. So phosphorylation. All right, making fructose biphosphate. Well, fructose, guess what, is an isomer of glucose. Just means it's shaped a little bit differently. So fructose still has 6 carbons. All right, shaped a little bit differently than glucose, and we added those phosphates on the end, making it pretty highly charged. Phase 1. Phase 2 is the lysis phase. What does lyse mean? Huzzah! So do to your neighbor, you ever play that game where you go, huzzah! You gotta move, right? Go ahead and try to karate chop your neighbor real quick. Karate chop him, come on. Give it back to him. You're supposed to dodge. You gotta dodge a little bit. Come on, Happy. Happy, I don't see any karate chops. Instead of saying, okay, now, you understand what we're doing?
Yes.
You understand what we're doing? Now, instead of saying huzzah, you have to say lysis. Do it to your neighbor, come on. Lysis. Huzzah, lysis. Do it. Come on! Gosh, gosh. Come on, Simone, go get Sean, real quick. Go get him.
Oh my gosh, you're dead.
No, this game is really violent.
All right. So, at this point, after you karate chop somebody and you lice them in half, fructose 1,6-biphosphate is split into 2 3-carbon molecules.
Can the class that you're recording this for hear you?
Yeah.
Oh god.
Called G3P, P-gal. All right, so now we got these P-gals. Woohoo! All right, so we got that. We already talked about that. All right, let's move on. Phase 2. Phase 3, oxidation. Oxidation
GCP what?
is P-gal. G3P is P-gal. Oxidation, all right, is Leo.
He loses electrons.
Leo, the lion goes dark.
Leo the lion goes grr. All right, Leo goes grr. All right, so each G3P, each P-gal, I don't like G3P, let's do P-gal. I like P-gals a lot better than G3Ps. Is oxidized. What does oxidized mean? It
Gains electrons.
Gains.
Loses
All right, so P-gal, let's make sure we understand this. P-gal loses electrons, and NAD plus is reduced to NADH. So what is it going to do? Gain electrons.
So it's basically the opposite.
It's the opposite of what you think.
Yeah.
It's the opposite of what you think.
Reduce, you were thinking.
Yes. Yes. You get more when you reduce.
Yes.
Yes. All right.
It's so dramatic.
What's that? I'm recording it right now. It is on YouTube. One day I'll get a view. I swear to God I'll get a view. Thank you. All right. This one will be entertaining. All right. Now each P-gal phosphorylates. Phosphorylate. What does that mean?
Gains phosphate.
Adds a phosphate to make 2 ADP to make 2 ATP, which is a total of 4 ATP. Well, why is it a total of 4 ATP? What the heck? 4? Why is it 4?
So isn't it diphosphate?
No, it's not diphosphate. Yes! Yes! 2 P-gals. What's better than 1 P-gal? 2 P-gals. I don't want to go to the dance with 1 P-gal. I want 2 P-gals. Oh yeah, because 2 P-gals came from 1 glucose. No, I just get fired up. This is like the stuff I majored in, so I love it. Love it. All right, so 2 P-gals come from 1 glucose. All right, so now we have 2 of them. See, look. See this? Look at this. See this? What's this? What do we call this? What is this?
P-gal.
P-gal. So we have 2 of them. 2 of them. And, oh, wait a minute. Let's see. So each 3-carbon molecule now has a second phosphate. Oh, if it has a second phosphate, what does that mean? It's
Diphosphate.
It's a
yes! Who said that?
Of course,
Yes.
Neil.
I did. What?
No, Simone.
Oh.
Neil takes the credit.
More energy from another phosphate. All right, more energy from another phosphate. And then, now, let's see. High energy electrons and hydrogen atoms are removed from the 3-carbon to create NADH. So, what happens right here? What's this process called?
Production.
Reduction, reduction, reduction. Why is it reduction?
Because it's gaining
It's gaining hydrogen. It's gaining hydrogen, gaining the energy.
Okay, it's gaining an electron. Remember what we did earlier? A positive plus a negative electron equal a hydrogen. So if you see it ever gaining a hydrogen, it is reduction. Done. If you see all of a sudden you're like a plus sign and then you see a hydrogen, reduction. Like if you see all of a sudden like Q47 plus and then Q47H, reduction. Reduction. You're gaining by reducing. Alright? So if you see an H that you didn't see before, it's reduction. Okay. Alright, and then we also added some hydrogens in here from that. Now it's happening twice. Don't forget it happened over here too. So we have reduction going on over here. I'm really filling out this chart for you, right? Okay. Now, all of a sudden we come down, we got some ADP. We need to make some ATP. High energy phosphate to remove 3 carbon and use to make ATP. So we're going to yank off, look at, let's check this out, ready? So I'm going to go ahead and go into blue. All right, so let's see. Now a second phosphate added, we remove that. We're going to yank these off. And guess what's going to happen? They're going to go right into that. And then all of a sudden we're left with these 3 green, become 3 purple. Now, why did I need 2 yellows? Because this is 2. So I need 2. I'm going to make it a yellow P. All right, here we go. See that? 2P or not 2P? That is the question. Only before community. 2P or not 2P? Only before community. Okay, so we need 2P to make 2 ATP. All right, so each one's going to give us a 2. We're going to take it off, we're going to yank it, and then we're left with 2 pyruvates. All right? I usually call those hot dates. You can call them pyruvates, whatever you want. I call them 2 hot dates. All right, well then. All right, glycolysis makes a net of 2 ATP for use by the cell. Why is it netting 2? How many did I just make?
4.
I just made 4. Well, wait a minute. Why am I only making 2?
Because you used to.
I used 2 to start the reaction. To start the reaction. RXN. Okay, I used 2 to start the RXN. Remember, we had Katie's water bottle, and I tried, Obi-Wanned it. I Obi-Wanned it as much as I could, and nothing happened. I had to add some ATP. Okay, that's it in a nutshell. We'll get to finer points in just a minute. I have a wonderful little video for you, and then we're going to take a 5-second break.
Cells derive energy from the oxidation of nutrients such as glucose.
I'm way better.
The oxidation of glucose to pyruvate occurs through a series of steps called glycolysis. The energy released during these oxidation reactions is used to form adenosine triphosphate, ATP, the energy currency of the cell. The initial steps in glycolysis are the additions of 2 phosphates to the glucose molecule at the expense of 2 molecules of ATP. The result is a 6-carbon sugar diphosphate molecule and 2 low-energy adenosine diphosphate molecules, or ADP. This 6-carbon sugar diphosphate molecule is then split into 2 3-carbon molecules.
What do we call those?
Each of the molecules is converted through a series of steps to pyruvate. During these reactions, electrons are transferred to the coenzyme NAD+ to form NADH, and ATP is formed. Under aerobic conditions, the pyruvate is further oxidized to yield more ATP, and under anaerobic conditions, the pyruvate is converted into lactic acid.
All right, last slide, and then we're going to take a 5-second break.
Question. How come that other B didn't come in?
Like I said, I'm better. Okay? All right. Oh, sorry. Where does it occur? The cytoplasm. What is the reactant? Glucose. What are the overall net products? We got some ATP. We got 2 of them. We got 2 NADH. We got 2 3-carbon pyruvates. And is it with or without oxygen?
Without oxygen.
Without oxygen. We call that without oxygen. What do we call that? Anaerobic. Anaerobic.
Without.
Get out. We don't want any oxygen in here. Okay.